Alright, this is going to be the first video for my derivative series, and today we're going to talk about unsolved related rates and optimization problems. So let's get started. So a spherical balloon is inflated with gas at a constant rate of 900 pi cubic centimeters per minute. How fast is the radius of the balloon increasing at the instant in which the radius is 30 centimeters? Alright, so we have 900 pi. The units are centimeters per minute, so we already have kind of the volume, right? Cubic centimeters. So that will be the volume. And it's talking about at a rate. So I would assume that it is also the derivative in terms of the volume, dv over dt, right? And it's talking about a sphere, and the volume of a sphere is 4 over 3 pi r cube, and they are asking for the radius, the rate of the radius. How fast is the radius of the balloon increasing at an instant rate? So they are asking for dr over dt. So how we can have that resolved? How should we approach this problem? Well, we have dv dt, and also we have dv over dr. We can also have the rate and the derivative of the spherical balloon, and we can put a formula, right? So dv over dt is this result can be equal to the derivative of this. So this is in terms of the spherical balloon. So dv over dr times dr over dt. We know this one. So to get this, we have to get the derivative. So dv over dr, it is equal to 4 over 3 pi. This is a variable that, well, not a variable, but a constant that stays multiplying. The derivative comes, the power comes multiplying, and we subtract 1 to the exponent, and now that will be square. So these two, they simplify, and then we have 4 pi r squared. That's the beauty. That is it. We almost are complete. And then we just plug the number, so it would be 900 pi, and that is going to be equal to 4 pi. And what is the r? We have another variable. We don't know what is r, but you know the radius, 30 centimeters. So let me do this pi a little bit clearer so you can understand it, and then multiply dr over dt, and then the algebra, the basic algebra, dr over dt, 900 pi, and then we pass 400 pi square. I almost forgot it. 400 pi 30 square, right? And then 30 square is 900, so both of these simplify. The pi also simplifies, it's in the numerator and denominator. So dr over dt is going to be equal to 1 over 4. But not just that. Remember the units, because teachers get mad when you don't put the units. They put me like -5 points in one problem because I forgot the units. So centimeters per minute. That is it. Right, so next problem is going to be about the one related with related rates. This is a common one, the airplanes problem. So an air traffic controller spot two airplanes at the same altitude as they fly at right angles, as shown in the figure. One airplane is 225 miles from the origin, moving at 400 miles per hour. The other airplane is 200 miles from the origin, moving at 550 miles per hour. At what rate with respect to time is the distance s between the airplanes decreasing? So let's get with the problem. So we have two airplanes, right? One is 225 miles from the origin, so that's where x or y is going to be. That's the point in the graph. Here is a triangle in which it's going to be. So 225 miles is going to be here, right? We have the graph and the figure shows near 200, close to 250. So we can put that x is equal to 225 miles. And it's also saying that it's moving at 400 miles per hour. So velocity can be in terms of derivative, right? So that will be dx over, in terms of time, dt. And that is going to be equal to 400 miles per hour. But here's the catch. Here's where the professor wants to kind of trick you. Because it's going to the left, it's decreasing. I mean, even though it doesn't say it on the problem, they want you to confuse you in that part. So let's put a negative sign. And then we also have the other airplane that is at 300 miles from the origin. So y is going to be equal to 300 miles. And the velocity is dy over dt, and that is going to be equal to 550 miles. But it's also going to be negative, so I was also missing that. So we have y and we have x, right? So we can get s, the hypotenuse, using the Pythagorean theorem, right? The sum of the angles, the sides square is going to be equal to the hypotenuse square. So 300 square plus 225 square, and that is going to be equal to s square. So 90,000 plus 225 square is going to be 50,625 s square. So we take the square root of this and the square root of this, and we're left with, I already did I already have it in my calculator, so it's going to be 375. So that is going to be s. So we already have s, right? So it's going to be 375, but they are not asking for s. They are asking for the rate of ds. So it's going to be, they're asking for ds over dt. We don't know that. So how should we get it? I would say that we can use the Pythagorean theorem, right? We can set that x squared plus y squared is going to be equal to s squared. The same as we did here, right? But we already have the values, and we can use the derivative in this case in both sides to plug the velocity. So if we do get the derivative for dt, we should get that 2x dx over dt plus 2y dy over dt, and that is going to be 2s over ds over dt. So we have here our variable, and we already have all these variables, right? And we can even simplify 2, 2, and 2, both sides. And we then have to plug the numbers. So 225 times minus 400 plus 300 times negative 450. And that is going to be equal to 375 ds over dt. So 225 times negative 400, that is going to be equal to negative 90,000 minus, I right here my calculator, is going to be equal to 150,000 over 375. We already passed this divided to divide ds over dt, and then it's going to be equal to 240,000 over 375 ds over dt. So at the end, when we divide, we're going to get that ds is going to be equal to negative 640, but not that. That's just not the answer. Remember to put the units, because teachers get mad, professors get mad. I get flashbacks from my professor putting a big fat -2, and I had to do my problem each time they didn't put the units. So always forget to put the units. So look it back, and then respect to time, so we put miles per hour. And that's it, negative 640 miles per hour. Thank you.